Hello friends, in the previous lecture we have to study the aldol condensation reactions and cross aldol condensation reactions. Today's lecture we have to study about the Cannizzaro reactions. In the Cannizzaro reaction takes place only for the aldehyde molecule, does not take place for the any ketonic molecules or carboxylic acid molecules, only takes place for the aldehyde molecule. Very simple meaning of the Cannizzaro reactions is aldehyde which do not have alpha hydrogen atom on heating with strong alkali to undergo the self oxidation or reduction reactions or redox reactions. This type of the redox reactions or disproportionation reaction is called as a Cannizzaro reactions. Very simple meaning for the Cannizzaro reaction is aldehyde which do not have alpha hydrogen atom on heating with strong alkali to undergo self oxidation or reduction or redox reaction. This redox reaction or this disproportionation reaction is called as Cannizzaro reactions. Very simple meaning of the Cannizzaro reactions: when the aldehyde which do not have alpha hydrogen atom on heating with the strong alkali like 50% NaOH, 50% KOH to undergoes self oxidation or reduction reactions, or it is also called as a redox reactions. This redox reaction is also called as a disproportionation reactions. This disproportionation or redox reaction is called as a Cannizzaro reactions. In the Cannizzaro reaction is second important point. In this reaction, one molecule of aldehyde is oxidized to give corresponding salt of carboxylic acid and second molecule of aldehyde is reduced to give alcohol, the alcohols. In the second important things in the Cannizzaro reactions, in this reaction, in the Cannizzaro reaction, two molecules takes place for the requirement for the reaction for Cannizzaro reaction. One molecule of the aldehyde do not have alpha hydrogen atom is oxidized to give the corresponding salt of the carboxylic acid, and second molecule of the aldehyde is undergoes the reduce to give the particular alcohol or corresponding alcohols. In this reaction required two molecules of the aldehyde and which do not have alpha hydrogen atom. Out of the two molecules, one molecule is the oxidized and remaining molecule is the reduce. In this way, this reduction reaction and oxidation reaction takes place in the simultaneously. In this way, it is called as a redox reactions, or also called as a disproportionation reactions, and this type of the overall reaction is called as a Cannizzaro reactions. For example, suppose that, for example, formaldehyde, two molecules of this one is the formaldehyde. Formaldehyde react with 50% NaOH heat to give sodium formate. This molecule is the sodium formate or corresponding salt of sodium salt of formic acid is also called as a in short sodium formate, or remaining molecule is the CH3OH means methanol. This two product, this one is the oxidized product and this one is the reduce. Oxidized and reduce, this one is the oxidized product is the sodium formate, and reduction product or reduced product is the alcohol means methanol. This type of the overall reaction is called as a Cannizzaro reactions. In the another example for the Cannizzaro, this one is the first example. Second example, suppose that benzaldehyde, two molecules of the benzaldehyde react with 50% KOH, then gives plus. This one is the potassium salt of benzoic acid or potassium benzoate, or this one is the benzyl alcohol. These two products are gives here. In the formaldehyde does not contain any alpha hydrogen atom, or it is benzaldehyde, it is also does not contain the any alpha hydrogen atom. This type of the aldehyde they will be takes place for the Cannizzaro reaction. Both the formaldehydes and benzaldehyde any does not contain any alpha hydrogen atom. In this way they easily takes place or easily react with the strong alkali like KOH or NaOH, and one molecules of this aldehyde are oxidized, then gives the corresponding salt of carboxylic acid, and another molecule is reduced, they will be corresponding alcohols. Then one molecule is oxidized, gives the oxidized product is the salt of acid, and reduced product is the alcohol. This overall reaction is the Cannizzaro reactions. And second one is the next topic is the cross Cannizzaro reaction. Very simple things of the cross Cannizzaro reaction is two different aldehyde we have to take place. Next topic is cross Cannizzaro reactions. Cross Cannizzaro cross Cannizzaro reaction. Very simple meaning for the cross Cannizzaro reaction. When two different aldehydes which do not have alpha hydrogen atom on heating with strong alkali to undergo self oxidation or reduction or redox reaction is called as cross Cannizzaro reactions. Cannizzaro reaction. For example, very simple meaning of the cross Cannizzaro reactions. When the two different aldehydes which do not have any alpha hydrogen atoms on heating with strong alkali to undergoes the self oxidation or reduction or redox reaction is called as a cross Cannizzaro reaction. Suppose that one molecule is the formaldehyde and another molecule of the benzaldehyde, they will be takes place. They will be react with the strong alkali, then gives the one molecule is oxidized and remaining molecules is reduced, then gives the one is the corresponding salt of acid and another is the alcoholic product. For example, suppose that formaldehyde which do not have any alpha hydrogen atom, and second one is the benzaldehyde. It is does not also any aldehyde. Two different aldehyde you have to take in the starting materials. Then they will be react with the 50% NaOH. In this situation, smaller molecule is oxidized and bigger molecules of the aldehyde, big molecules of the aldehyde is the reduced. In this meaning of the oxidized is this formaldehyde is the smaller molecule as compared to this benzaldehyde. This formaldehyde is oxidized and gives the corresponding salt of acid, and the benzaldehyde is big size as compared to this formaldehyde. In this way, this type of the molecule generally reduce and gives the alcoholic product. For example, formaldehyde is oxidized, gives sodium formate. This one is the smaller. In this way there will be oxidation, and remaining is the this molecule is the form from the benzaldehyde. They will be after the reductions. In this way they will be benzyl alcohol. They will be reduced product. After the reductions they will be formed. Here it is the two different aldehyde takes place here, goes on the reaction of Cannizzaro reactions. In this way, this type of the reaction is generally called as a cross Cannizzaro reactions. The very simple meaning of the cross Cannizzaro reactions. After this cross Cannizzaro reaction, suppose that this sodium formate is also acidify with the H3O plus. Suppose that this sodium formate is acidify. This one is the does not acidify. This is the conform product for the alcohol, but this product is any salt of corresponding acid. They will be acidified to give the corresponding acid. For example, this sodium formate is acidified with the H3O plus, then gives the product like formic acid. This one is the formic acid. This is the overall reaction is called as a cross Cannizzaro reactions. Next topic is the oxidation and reduction of the aldehydes and ketones. Next one is the oxidations and reductions of the next topic is the oxidation and reduction of the aldehydes and ketones, particularly oxidation of aldehydes and ketones by diluted nitric acid, potassium Kemenophores and K2Cr2O7 means potassium permanganate and potassium dichromate in acidic medium. This overall the oxidizing agent is the diluted form. In this way it is the weak oxidizing agent or diluted oxidizing agent. This oxidizing agent oxidize the aldehyde. In generally suppose that in general reactions aldehyde react with these 1 2 3 diluted product gives the similar product. Suppose that first K2Cr2O7 in presence of diluted H2SO4 means in acidic medium. Suppose that second one, or suppose that this option of this reagent is second reagent. Suppose that this one is also diluted nitric acid in presence of acidic medium, or third one is diluted KMNO4 in presence of H2SO4 or acidic medium. This one is also right here, acidic medium. Gives the similar product. This one is the aldehyde. Both the types of the aldehyde, they will be react with the K2Cr2O7 in acidic medium like dilute H2SO4. There will be also another option for this reagent. Alternative reagent is dilute nitric acid in acidic medium. This dilute nitric acid is alternative reagent is the dilute KMNO4 in acidic medium. Both of which one reagents are react, then gives the COOH, means this aldehyde group is oxidized, then gives the carboxylic acid, means acid. Any types of the aldehyde react with this reagent, then gives the corresponding acid, and this overall reaction is called as a oxidation reaction of the aldehyde by diluted nitric acid, KMNO4, K2Cr2O7 in acidic medium. Similar thing in the, suppose that ketones. In the ketones, some important points note down here. Ketone resist oxidation due to strong CO bond. In the ketone, in generally, ketone resist the oxidation by weak reagents or diluted oxidizing agent or weak oxidizing agent due to strong in the ketone contains strong C double bond C bond. This bond is the very strong bond, does not oxidize or does not react this type of the diluted or a weak oxidizing agent, they will be oxidized, but they are oxidized by strong oxidizing agent such as CrO3. CrO3, they will be strong oxidizing agent. Another one is the alkaline KMnO4, concentration nitric acid to gives mixture of carboxylic acid having less number of carbon atom than the is in generally ketones. Some important point is oxidation of ketone is note down here. Ketone resists the oxidation due to strong bond, in which the ketone is the strong bond between the carbonyl group and another carbons. There will be very strong bond is present in the ketone, but this type of the ketones does not oxidize the mild oxidizing agent like the above three reagent. Both the three reagents are mild oxidizing reagent and does not react the ketonic molecule, this mild oxidizing reagent. But these ketonic molecules, they are react or they will be oxidized by the strong oxidizing agent such as CrO3, another strong oxidizing agent like alkaline KMnO4, concentrated nitric acid. This type of the strong oxidizing reagent are easily oxidize the ketonic molecules and gives the mixture of carboxylic acid. Why it is gives the mixture of carboxylic acid? Because having the breaking of carbon-carbon bond, because the mixture of carboxylic acid is used because the breaking of carbon-carbon bond in the ketone molecule. In this way, two different types of the ketones are gives. In this way, they will be called as a gives the mixture of carboxylic acid, which having the carboxylic acid which having less number of the carbon atom than the starting ketone. Suppose the starting ketone contains 3 carbon, then gives the mixture of 2 ketones. In the 2 ketone, one mixture of 2 carboxylic acid gives back from the 3 carbon ketones. One carbon is the carboxylic acid, another 2 carbon containing the carboxylic acid. This type of the 2 carboxylic acid gives the after the reaction of ketone, then gives the carboxylic acid or mixture of carboxylic acid. For example, suppose that for example suppose that R C double bond O R dash react with CrO3 strong oxidizing agent, then gives the RCOOH plus R dash COOH. This is the mixture of carboxylic acid. Particular example is, suppose that acetone molecules, this one is the acetone, react with CrO3 or alkaline KMnO4, then gives acetic acid, and remaining is the formic acid or methanic acid. This three carbon containing ketones. Here it is this bond is the break. This bond is the break, and remaining two carbon is containing acetic acid is gives after the oxidation, and remaining one carbon is break. In this both the acid, observe the one carbon is less in the starting material. Here it is the three carbons, but here it is the one carbon is lost by another formic acid molecules, and here it is only two carbon is available. In this way it is one carbon is lost. Another example, like suppose that C2H5, this one is the but 2 ONE. This molecule is also react with the strong oxidizing reagent like CrO3, then gives this one is the acetic acid plus C2H5COOH. This one is the propanic acid, then gives the mixture of two acid. One is the acetic acid and another is the propanic acid. In above reaction is also mixture of two acid, acetic acid, and another form of the acid is the formic acid. After the oxidation gives the ketone. After ketone is oxidized, and after the gives the product is the mixture of two acid. Here it is the totally oxidation of the ketone. Remaining one is the second part, reduction of aldehyde and ketones. Suppose that first topic is the oxidation of aldehydes and ketones, second topic is the reduction of aldehydes and ketones. In this way, first reaction is the, suppose that name reaction, a famous reaction, Clemmensen reactions. Clemmensen reduction reactions. The reagent of the Clemmensen is Zn amalgam in presence of con HCl. Very simple and famous reaction is when the carbonyl group of the aldehyde or ketones converted into the methylene group after the reaction of Zn amalgam in presence of concentrated HCl. This overall reaction is called as a Cannizzaro reaction. This Cannizzaro reaction is the simple meaning. Suppose that the carbonyl group, like in the bracket of aldehyde or aldehyde and ketones is reduced to methylene group like CH2-CH2. This group is called as a methylene group. On react with Zn amalgam in presence of con HCl is called as Clemmensen reactions. Is called as Clemmensen reduction reactions. For example, suppose that general example, here it is the any carbonyl group of the aldehyde also and ketone also. They will be react with ZnHg means zinc amalgam in presence of con HCl, then gives this carbonyl group is converted into the methylene group. This one is the carbonyl. This carbonyl group is converted into the methylene group. The very simple general reaction for the Clemmensen reduction reaction. Very simple meaning of the Clemmensen reduction reaction is the when the carbonyl group of the any aldehyde or ketone is reduced to methylene group on react with this Zn amalgam in presence of concentrated hydrochloric acid. This overall reaction is called as a Clemmensen reduction reaction. This Clemmensen reduction reaction is generally acidic medium reactions. In this way, the carbonyl group is easily converted into the methylene group. Means here it is this carbonyl group is reduced, oxidation is lost, and hydrogen is addition. In this way, overall reaction is the reduction reactions, and this type of the reaction is called as a Clemmensen reduction reaction. A particular example of the Clemmensen reduction reaction is suppose that particular example of Clemmensen reduction reactions. First example, suppose that CH3C11O CH3 acetone react with the 4 hydrogen then Zn Hg in presence of con HCl and heat to give the CH3 CH2 CH3. This one is the plus H2O. This molecule is the propane, and this one is the acetone. This carbonyl group is reduced after the reaction of Zn amalgam in presence of HCl, then gives the CH2, this methylene group, and this overall reaction is the Clemmensen reduction reactions. Another example, like suppose that CH3 CH2 CHO, this one is the propanol, react with Zn Hg in presence of con HCl, then gives CH3 CH2 CH3. This one is also propane, Here it is the last one. Aldehydic carbonyl group is converted into the CH3 group. Means one hydrogen already present here and two hydrogen is added. In this way, this type of the overall reaction is the Clemmensen reduction reaction. Next reduction reaction is the second one. Reduction reaction is Wolff-Kishner reduction reactions. Generally, this type of the reduction reaction is in basic medium. There will be hydrines in presence of base like KOH. This type of the reaction generally similar meaning when Wolff-Kishner reaction is simple meaning when carbonyl group of aldehyde and ketones is reduced to methylene group by hydrazine. Hydrazine means NH2 dash NH2 or N2H4. This type of the molecule is called as a hydrazines, follows by heating with NaOH or KOH is called as Wolff-Kishner reduction reactions. In generally very simple things, in the Wolff-Kishner reduction reactions, both the reaction Clemmensen reactions and Wolff-Kishner reaction, both the carbonyl group is converted into the methylene group, but different here it is the Clemmensen reduction reaction is the acidic medium reaction, but Wolff-Kishner reaction is the basic medium reaction. Here it is also general reaction is any carbonyl group is converted into the NH2 in presence of KOH. This one is the hydrazine. This hydrazine and in presence of base to give the methylene group. This one is the carbonyl group. Carbonyl group is converted into the methylene group. This is the general reaction for the Wolff-Kishner reduction reactions. Here it is the hydrazine in presence of KOH is the reagent for the Wolff-Kishner reduction reaction. Particular example of this reaction is, suppose that propanol, two-step reactions of the Wolff-Kishner reduction reactions. Particular example for example, suppose that first example C2H5CHO means propanol react with NH2-NH2. This one is the hydrazine. This molecule is called as a hydrazine. there will be water molecule is removed here, then gives C2H5 CH double bond N NH2. This one is called as a hydrazone. And these hydrazones are react with the base in presence of glacial acetic glycol or used as a solvent. This one is the solvent glycol. And this ethylene glycols in presence of base then gives the particular product is propane, and nitrogen gas is liberated in the reactions. This one is the particular example for the propanol, means propanol aldehyde is react with the first step in the hydrazines, and after the reaction of the aldehyde and hydrazines then gives the hydrogen molecules. These hydrogens are react with the KOH in presence of ethylene glycol. This ethylene glycol is the solvent, and this ethylene glycol and KOH they will be takes place in the follows reaction, then gives the propanes. Means overall reaction is this carbonyl group is converted into the CH2 group. In the overall reaction is called as a Wolff-Kishner reduction reaction. Similar thing, second example for the, suppose that this molecule is the ethyl phenyl ketone. This ethyl phenyl ketone react with the hydrazine NH2-NH2. This lone pair of electrons they will be attacked here, and this water this oxygen molecule is removed, and this here hydrogen is lost, then gives this type of the molecules like hydrazone is gives here C2H5 this type of the molecule is generally called as a hydrazone. This hydrazone they will be react with NaOH in presence of ethylene glycol, then gives C2H5. This molecule is called as a N-propyl benzene, and byproduct is nitrogen gas is liberated here. This overall reaction is the Wolff-Kishner reduction reaction. This Wolff-Kishner reduction reaction is the particular basic medium in the two-step reactions. Clemmensen reduction reaction is the one-step reaction. It is the two-step reactions. In this simple thing, first step is the gives hydrazone, and these hydrogens are react in the second step is the strong base like KOH or NaOH in presence of solvent like ethylene glycol, then gives the particular corresponding molecules like N-propyl benzene, or here it is the propane. This overall reaction is called as a Wolff-Kishner reduction reaction. Here is the aldehydes and ketones both are reacted here. Suppose that these two molecules, one is the aldehyde and remaining is the ketones, both are the react with the Wolff-Kishner reduction reactions. Remaining topics of this chapter they will be discussing about the next lecture. remaining chapters. Remaining topics of the remaining topic of this chapter is they will be discussing about the next lecture. Goodbye.